All right, so the ones I want to go over right now are tests for unsaturation. So the ignition test, we're going to use potassium permanganate as well as bromine and methylene chloride. Okay, so we can check out those right about now. Okay, the ignition really I'm not gonna say it's lame because you get to light stuff on fire, but it's not super instructive. Maybe it is. If you burn it, you burn your sample with a spatula, and you're gonna get a yellow flame, and then it's like smoky, sooty flame. That means you probably have an aromatic species. If it's not sooty, like no black smoke after or anything, then it's not aromatic. But sometimes you could have something that might be aromatic, so you might want to have another means to confirm. But yeah, it is kind of obvious, so you'll see. Check it out. All right, so remember what we're looking for is a black sooty flame for something that's aromatic, and then the absence of that black soot. What's something that's not aromatic, and it's pretty obvious. You'll see here as I put the aromatic compound in there, we got black soot. It's just smoky, right? It's very obvious. Definitely something gross that you don't want like in your campfire, right? Whereas this one is gorge. It looks amazing. It looks like a nice little fire, hot flame for us to enjoy fireside. Maybe cook some s'mores. All right, so that's it. Straightforward. Okay, so potassium permanganate to test for unsaturation. So first things first, be careful. Don't be scared, but be careful. You have to watch out for false positives, right? So potassium permanganate does react with alcohols and aldehydes and amines, depending on what kind you have, right? So just keep that in mind. But yeah, proceed with caution, but you can use other things to decide if you have those functional groups. So looking at straight up double bonds is what we're doing right now, and it's very obvious. What you want to do is you're going to start off with a provided potassium permanganate solution, and then you're just going to dissolve about 2 drops or 25 milligrams or so of your unknown compound inside of ethanol. So we have 95% ethanol. We're going to dissolve it in that. Also a reason to be careful. So if you have an ethanolic solution, you don't want to let it sit around for too long and then interpret the results then. So you observe immediately, maybe 1-2 minutes. Okay. Sorry, I'm jumping all over the place, but just want to like make sure that I hit these like, oh, be careful, watch out. Oh, stop, no, red light, go. Okay, so, we've got our sample, unknown sample dissolved in 95% ethanol. Now what we want to do is drop a roux of potassium permanganate and observe what happens. So, a positive result, that it's a beautiful purple. I swear you're gonna love it. Just don't get it on you, because gross. Strong oxidizing agent. Okay, so once you drop it in there, if the color persists, that beautiful purple, it's negative. Okay, that means you still got your potassium permanganate floating around, just ready to react with something, but there's nothing there. So sad. But if you drop it in there and then you start seeing some changes, maybe a brown precipitate, then what that means is that you have an unsaturated compound. It reacted with maybe a double bond, right? So this potassium permanganate, KMnO4, reacts with a double bond, for example, and you get manganese oxide. So that's the brown precipitate that you're going to see. That's what you're looking for a positive result of an unsaturated compound. Okay, it's pretty straightforward. Take a look. In my opinion, it's very obvious because such a vibrant, beautiful color, or not, right? Okay, check it out. All right, let's take a look. See, I've got my hexene here. It's an alkene, right? So I got my alkene, I got my 1% potassium permanganate, KMnO4. This is a provided solution. You won't be required to make this, but just do a little droppity drop in here. Remember, slowly, of course. Make sure you have control of the liquid in the pipette before you move it over to the tube. And then 1, 2 drops, and then observe. I'm taking a look at it. It looks pretty cool, I must say. Give it a little shake, mix it up. That purple, it's not that vibrant purple anymore. You can't really see like an obvious precipitate or anything, but there's definitely a color change, right? From that gorgeous purple. There you go. Added a couple more drops just to see if we see any significant or obvious change. But there you go. Looks like a poopy brown to me. I don't know about you. I mean, brownish, right? Brown-esque. All right, so now let's go ahead and set that aside and take a look-see at something that does not give us a positive confirmation of the presence of an unsaturated bond. Okay, so KMNO4 does not react with this compound, and it stays that gorgeous purple color. Okay, obviously it might turn a little bit more pink because it's a little more diluted, but it's still a pretty color. And yeah, there you go. That's it. Pretty much. Remember, you don't want to let this sit for too long before you observe any changes and record those and use that data, because this is an ethanolic solution. But comparing again, you can see, yeah, gross. All right, bye. Okay, let's go. So, test for unsaturation using bromine and methylene chloride. So what we're doing here is we are going to test a couple samples, some saturated, some unsaturated, just to see what a positive test looks like and what a negative test looks like. So for bromine and methylene chloride, it's a 2% solution of bromine and methylene chloride. So it is diluted, but bromine is one of 2 elements on the periodic table that is actually a liquid at room temperature. So pretty neat, right? Other one being, anybody know? All right, we'll see. But bromine reacts with double bonds, right? Triple bonds too, and it reacts with unsaturated compounds. And since it's got that beautiful red color, when you put red in, and the bromine is the red, and it reacts, and the bromine's no longer around, then that means the red's no longer around. So that's essentially what we're looking for. So you take 50 milligrams of your unknown sample, solid sample, or 4 drops of unknown liquid, and then you place that into a test tube with 1 milliliter of methylene chloride, just to dissolve it. Then you hit it with 2 drops of your 2% bromine and methylene chloride solution, and you observe. What are we observing? Well, what we're going to observe is whether or not the color stays or it goes away. And that's pretty much it. It's easy in theory. Okay, so the problem, methylene chloride, as you know, likes to just jump out of your pipette, right? So you have to be really careful, because you really want to just start with 2 drops of that bromine solution, because if you add too much, the color is probably going to stay, even if you do have an unsaturated compound, because it's going to react, and then you're going to have an excess of bromine, and then it's going to stay red. Okay, so what you want to do, drop by drop, be careful, observe, give it a little shake. If the color stays, add a little bit more. Or I'm sorry, if the color stays after 2 drops, then it's a negative test. You do not have an unsaturated compound, right? So, or basically, I guess you do not have a compound that would react with bromine, I should say. And so, if it goes away though, add a little bit more. And if you had 5 drops, color keeps going away, then you probably have something that is reacting with bromine, right? So there's a couple different ways that a compound can react with bromine. So that could be addition or substitution. So if it's addition, like across a double bond, bada bing, bada boom, you just get bromine added to it, right? And the color goes away. If you have substitution, then you're going to get the formation of HBr. So that HBr could present itself as a fog in that test tube. What I like to do, give a little squeeze. I mean, like sometimes it's suggested like you blow into it. I'm not about to blow. No, I don't know. It seems silly to me. So I just give it a little like squeeze of air from the test tube or from the pipette into the tube, and then just kind of see what happens. So, dang, I need that earbud. I bought a earbud, so I'm stoked about it. Yeah, that's it, right? Super easy. Let's see what happens, and then you get to see what it looks like. I would say if you're ever unsure, just test it again. Because what's 4 drops of your unknown? What's 50 milligrams of your unknown? Not a big deal, but to be positive or sure about what you actually have in your test tube, that's priceless. You know what I'm saying? You know, that MasterCard thing. All right, there's my samples all prepped because you know how we do. Now I got 2% bromine and methylene chloride. It's got a beautiful color as well. All right, so here's my alkene. It just so happens to be cyclohexene, but here's my alkane. Let's see what happens with that. We're gonna mess around with a little aromatic compound, toluene, and we're also gonna play with acetone, a ketone. Okay, very basic ketone, the most basic. Okay, or the simplest form, I should say. Let's go. Okay. What happens when I drippity drop that bromine into my alkene? Okay, so we said an addition reaction. Bromine that'll drip all day long. Whoa. All right, did you see anything? I didn't see anything. The alkene is reacting with it, so that beautiful red color is disappearing. It drops in and it's gone. It's like it never happened. Okay, so here's the thing. You want to add slowly, and then you might want to just keep adding and see what happens. Maybe it'll eventually stay colored, and that just kind of means that you consumed all of the alkene, right? If you add 5, of course, like I mentioned, then it's pretty solid confirmation that you have an unsaturated compound that's reacting with the bromine. So let's move on, and that's a positive, right? That's a positive result. So what else can I do? Bring it in. We're doing an alkane. All right, see what happens. Look at that. Boom. Oh, can you see the color? Drippity drop. If you drop, pay close attention. You can see it kind of settling at the bottom. Let me see if I can show you a better look. It's tough to see, but it's obviously much easier in person, though that 2 drops is still present at the bottom. It looks kind of like a yellow, maybe orange color. Okay, so let's just add a couple more because that's what we did. Boop. All right, it's there. Yeah, it might not be super obvious in the video, but I think as long as you're not like colorblind and you can see those colors. Oh, there it is right there. Woo. There it is. All right, so that means, that's actually a little bit better once you shake it, right? You get the yellow color-ish. So now let's check out another sample. So this is an aromatic compound, okay? So some aromatic will actually react with bromine, okay? With just bromine by itself. Those have to be aromatic compounds with strong electron donating groups. So like I drew in the image, the OH on there, the phenol, that one will work. And what you'd get is the color not persisting like this color is. Okay, so you need that. Again, you need that strong electron donor. By the time we perform this experiment, you will know exactly what I'm talking about. But for now, toluene with benzene ring with just a methyl on there doesn't react with it. Bromine by itself. All right, let's try the next compound, but hush real quick, because we don't talk about ketones, no. Okay, but yeah, for real though, we do talk about ketones, and we got to test that. So, let's see what happens. Okay, we'll just drippity drop like usual, and then watch the magic happen. Because it's there, and then watch. It's there at first, and then it's not. What? Are you serious right now? That's magic. Chemistry is magic. All right, give it a little shake, make sure. Okay. All right. Voila, no color. There you go. All right, so as you can see, these tests are really easy. The only thing you really need to keep an eye out for is adding too much initially, right? So like I said, methylene chloride can straight up jump out of that pipette and you'll add more than the couple drops that you want. And then if you've added too much and it's reacted or completely consumed your unknown product or unknown materials, then you won't get the proper reading, okay? So just be careful, that's it, okay? So all I'm doing here is just adding more just to make sure that we're good, right? I always gotta, and maybe see how much I can add. How reactive is this compound, right? Okay, so shake your groove thing, yeah, yeah. That's what's in my head right now. Sorry, anytime. Life is music, music is life. No color, so now I'm just gonna double check everything else. That's my toluene. The aromatic compound is still yellow, has not reacted. And as we double check all of the unknowns, the results are the same. Okay, we're good to go. Okay, y'all are stoked right now because we got that remix to ignition. It's hot and fresh out the kitchen. Jess is rolling that body, got every man in here wishing. Okay, sorry, I went way too long. I always go way too far, you know. Bilstein, pretty much samesies. What I got here is a little copper wire. You see it? You see it? Right here. And I just kind of like made a little loop at the end, and we're gonna dip it in some sample, put it in the flame of the Bunsen burner. If it burns green, what that means is that we have a halogen present in that compound. It doesn't specify whether it's chlorine, iodine, fluorine, or bromine or anything, but it does tell us we have a halogen. So this is really useful if we've kind of narrowed it down to a compound that does have a halogen and one that doesn't, right? Or you can just immediately say like, oh, it does have a halogen or it does not have a halogen from the beginning, right? This is really easy to do. You just burn stuff. It's super fun, especially if you get some pretty colors. But yeah, so what you're probably gonna see is boom, fire, orange, and then you're gonna see some green, or just burn, fire, orange, and then like no green, okay? So what the green is since this is a copper wire, we're actually creating little copper halide compounds that are beautiful, and they're volatile, and so that's why we get to see them kind of boom, like magic, okay? And so first things first, you want to go ahead and burn this. I've already burned it to create like a copper oxide layer on the outside, and then go ahead and start. This is copper, right? Conducts heat really well. So you might want to make a longer piece than this, maybe even hold it with something else. Maybe make like a loop, little handle on the end, just so that you can not burn your fingers when you're like lighting stuff on fire, right? So, because it does conduct heat really well and it gets hot. So what I'm going to do is I'm going to show you what a positive result looks like, and I'm going to show you what a negative result looks like. And so let's take a look. See, we're going to look at bromobenzene for our positive, so a compound with a halide. Then we're going to look at benzoic acid, one without. Okay. All right, let's go. Okay. Simmer down. That's a good looking flame right there, so hold it in. Let it like, got a little color to it, huh? You see that green? Gorgeous. Okay. Now, don't hold it in there too long, because that copper gets hot. Okay, so what I'm gonna do is I'm gonna do something else. reaction. Nope. 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 Where is it? Where is it? We're not going to hold it in too long. Okay. I got a little bit of sample in here. All I'm gonna do is dip, 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 hooray! Light it on fire. Ooh, whoa, look like some Harry Potter stuff right there, huh? What do you think? That was pretty cool. Let's see if we can get that angle better. Alright, let's see. You don't want to dip this in right after you put it in the fire because it's hot. You want to put hot stuff inside of a flammable liquid or what presumably is a flammable liquid. So take your time, don't rush. Don't rush. But so cool. Alright. Let's see. Ooh, oh, watch that green. Whoa! Expelliarmus! Patronum! Whatever other Harry Potter word there is. Okay, so that was a liquid. Super easy to do. I didn't leave. You never leave your Bunsen burner unattended. I didn't leave. I was still here. Y'all just couldn't see me. Here's a solid material. So trying to test the solid material is a little bit harder when you got your loopy-loop here, right? So we'll do our best though. So what I do is I kind of just get a little solid material kind of thrown right on top of it. And see? So this is what happens. You just struggle for a minute. Struggle. It's not chemistry lab. It's definitely not alchemy. You're not struggling. Come on now, let's see what this is. You know, okay? Okay. I'm supposed to be like, just throw it in the fire, like, I don't know, do you do any probably? Just throw it in the fire? Yeah, if they don't, they should. If they don't, they should. Okay. There you go. Kind of looks like delicious salt from a pretzel. There's like pretzels. Little Annie's pretzels. Alright. Try my best. I'm failing now. Roll it. Boom. Big chunk. What I did is I rolled this one up real nice so I could actually fit something, just kind of set it right on there. What's up? Boom. Ooh, so it was a flash of green. Really good. Flash of green could be that this particular compound had halogen in it. However, since it was just like real fast, could have been a little bit of residual from before. So you always want to maybe double check that, throw on some more stuff, see if you can't get the same results. Well, that time we didn't really see any green, so to me, most likely that means that there's no halogen in this solid material, but most definitely in the liquid material. So